Good morning. My name is Olivier, and I work at Igalia, and I'm going to discuss work on SteamOS and the impact it has on the broader Linux ecosystem. So in 1998, about 27 years ago, Valve released Half-Life, a game which had a lasting influence on the first-person shooter genre. Back then, I was 15 years old, and boy, how many sleepless nights did I spend fighting aliens to take Gordon Freeman through Black Mesa. And also countless hours designing and testing maps in the map editor that was called WorldCraft. Those were really good times. That game only ran on Windows, and at the time, I don't think I was particularly concerned by this limitation. In fact, my experience with Linux and other OSs was anecdotal back then. Fast forward 15 years, in 2013, Valve released the first version of SteamOS, which was based on Debian, followed by version 2 in 2015. Version 3 was initially based on Debian, but it was later rebased on Arch Linux during the development cycle. The latest stable release is 3.6, and 3.7, currently in the beta channel, is just around the corner. Making Linux work as well as possible for as many games as possible is a very large effort. For a few years now, we've had people at Igalia collaborating with Valve in the development of SteamOS. So we have a number of kernel developers, graphic drivers experts, multimedia hackers, CI wizards, and OS integrators, all contributing to the project, along with contractors from several other consultancies, all of this under the direction and coordination of Valve. I myself joined the project recently in December last year. And I'm going to try to give an overview of the contributions that my colleagues have made to SteamOS in the past, and those that we're working on today, and their impact on the broader Linux ecosystem. But before I dive into specific contributions, let's have a quick look at what the hardware side of things looks like. So the Steam Deck was made available in 2022. It sports an LCD display, an AMD Zen 2 CPU, and an RDNA 2 AMD GPU. At the end of 2023, an OLED version was released with newer Bluetooth and Wi-Fi support and a better battery. What's really interesting is that the development of SteamOS isn't constrained to one single device or family of devices. In many ways, SteamOS is designed as a general-purpose OS with a strong focus on gaming, of course. So one interesting example is that there's the default gaming session, of course, which is known as GameScope. That's also the name of the microcompositor that it runs. And there's also a fully featured KDE Plasma session. And switching from one to the other is a fully supported use case, not an afterthought. A lot of care is taken in making sure that the desktop session works well. And now there is a new Legion Go S made by Lenovo that's available with SteamOS pre-installed. So it's going to be interesting to see what new devices come out in the future with SteamOS as their base operating system. What's for sure is that the availability of several devices means that SteamOS becomes ever more relevant, and the contributions that I'm going to talk about as a consequence, have a greater impact on the entire Linux ecosystem. I think I said it already, SteamOS is a huge effort, and there are many teams that contribute across the stack, including working on Mesa drivers, conformance testing for Vulkan, Vulkan Video, GStreamer maintenance, Proton maintenance, etc. I'm not going to talk about everything, that's a lot, but let me dive into some of the most interesting contributions that have happened lately. And let me start with contributions to the Linux kernel targeting various subsystems. With a big word of disclaimer, I'm not a kernel developer. So since version 6.6 of the kernel, the default scheduler is EEVDF, the earliest eligible virtual deadline first. And since version 6.12, we have the SCADEX framework, which allows writing custom schedulers using BPF. My colleague, Changwoo Min, has been working on a custom CPU scheduler designed specifically for gaming workloads. He calls it LAVD, which stands for Latency Criticality Aware Virtual Deadline. LAVD in many ways resembles EEVDF, but it puts more emphasis on latency-sensitive applications, like games. The core ideas behind this scheduler are, one, measuring how much a task is latency critical, and two, leveraging this information in making various scheduling decisions. One important factor to take into account is that while there are some Linux native games, a vast majority of the games that are being played today through Steam are Windows games running on top of Proton. So this makes it impractical for games, if they were able to share latency hints with the kernel. And there are critical tasks, such as wine server when you run Proton, that would be penalized by a completely fair scheduler like EVDF. And that would result in an increased latency, the visible consequence of which might be a reduced FPS. And we know how FPS is an important metric in games. So one of the ideas in LAVD is to loosen the eligibility enforcement, which means it doesn't try to enforce short-term fairness, but it does try to guarantee eventual fairness. And they say a picture is worth 1,000 words. In this case, I think a video is worth even more. So let me show you a demo recorded by Changwoo a couple of months ago, which demonstrates the benefits of LAVD with gaming workloads. So this is Space Marine, a game that's available in Steam, and we're currently playing it with the default scheduler. As you can see, CPU usage is around 70%. We have a good solid 60 FPS. And the graph at the bottom represents the frame time, so the time it takes to render frames. It looks pretty good, pretty much a solid line. And now, wait for it, we're going to do something interesting. We're going to launch a CPU-intensive background job to see how well the game performs with that additional workload. As you can see, CPU usage bumps to 100%. The FPS drops to about 20-something, and the frame time is all over the place, and the values are not good. And the visible consequence is the game is lagging, terribly lagging, and it's not playable anymore, basically. And you can see even when idle, we're not actually moving in the game. That's not any better, or only marginally on the FPS side. Now, wait for it a little bit more. And we are going to launch the LAVD scheduler and see what happens. So what's pretty cool is that it's just replacing live the default scheduler. As you can see instantly, so CPU usage is still at 100%, but we regained a good number of frames per second. We're between 40 and 50 FPS. The frame time looks much saner, and the game becomes playable again. So there's a big improvement there. That's it for the demo. So there are many subtle details in LAVD, enough to fill an entire talk. so I'm not going to go into them. But if you're interested in the topic, I highly recommend watching the recording of Changwu's presentation, which he gave at the OSPM summit that happened in Germany in March this year. In itself, that's already a very interesting improvement to have a more suitable scheduler for gaming. But Changwu is taking it one step further. He's trying to identify how a general purpose scheduler can benefit from the work on LAVD. So in the future, we might see improvements to the default scheduler flowing in from there. Okay, let's have a look at another area. The DRM scheduler. So that's the component used by multiple GPU drivers to resolve dependencies between work submitted by user space, pick the most optimal GPU engine to execute those tasks, and also identify the best order of execution to balance interactivity and throughput. My colleague, Dvorko Ursulin, is working on improving that. So he's been working on alternative scheduling strategies which remove the current problems of priority starvation and improve fairness. The latest version of this work is the fair DRM scheduler proposal, which borrows some of the concepts of the default CPU scheduler and applies them to GPU scheduling. I must note that there are certain limitations derived from the fact that GPUs generally do not allow for fine scheduling precision. And to allow more modern use cases, he's been working on a DRM scheduling C group proposal, which is broadly speaking aiming to allow for external control of the DRM scheduling decisions. Because despite the fact that a lot of the GPUs and their drivers are able to prioritize execution between different levels, there is currently no way to convey the importance of tasks from the outside in a manner similar to the Linux NICE levels or CPU or I/O C group controllers and their relative weights mechanism. So the DRM scheduling C group controller proposes to add such a mechanism by building on top of the fair DRM scheduler proposal. That would enable interesting use cases, for instance, with window managers, which would be able to mark focused versus unfocused windows, and by doing so, improve the user experience by enabling lower latency rendering in the focused application. Or from the opposite angle, one could allow for deprioritizing background applications. Let's have a look at HDR support. So my colleague Melissa Wen has been working with the community to develop a generic kernel mode setting API. The goal is to allow user space to offload color transformations required for HDR and other tweaks that improve the overall user experience to the display hardware. This offloading is especially important in GPU-intensive scenarios, like gaming, as we can use dedicated display hardware blocks for advanced color management and save the GPU the work of performing such transformations through shaders. To support this discussion and provide experimental means of evaluating these capabilities on display hardware, we also exposed on the kernel side AMD hardware color capabilities through driver-specific properties. This work enabled the launch of the OLED Steam Deck, which I mentioned previously, with an integrated display with HDR support, and that provides Linux users with a better gaming experience. And this initial support in GameScope, in turn, served as a catalyst for HDR support in other parts of the stack. So the Plasma desktop, or GNOME, for instance, with the release of version 48 a couple of months ago with initial support for HDR. We also hosted last year the Display Next Hackfest that brought together different stakeholders in the Linux display stack to share knowledge and consensus. Our goal is to use all the resources available in complex and robust GPUs, like those manufactured by AMD, to provide the best experience and performance for the Linux user. All right, I'm changing topics, and we're going to have a look at a couple of interesting OS integration projects. My colleague, Alberto Garcia, has been working on enabling hard drive encryption, which is considered an important feature nowadays, especially for a portable device, which is more easily lost or stolen than a desktop computer. In fact, this is a feature that has been demanded quite vocally by users, and because it's not available out of the box, a number of tutorials and how-tos appeared on the internet with instructions on how to encrypt a Steam Deck. Not being official solutions, they're not necessarily future-proof, and they don't really offer guarantees. And the last thing you want is to lose your data because you're unable to decrypt it when you intended to protect that data in the first place. So Lux was considered, but there are several downsides to encrypting a whole block device, even though it is definitely the most secure option. Because encryption was not baked in from the start, one scenario that we're keen to support is encrypting an existing drive easily without requiring an extra backup. It should also be possible to remove the encryption if one wants to do that. So the approach that was chosen is to use fscript to encrypt selected directories. It's not the most confidential option. In particular, metadata and extended attributes are not protected, and it's theoretically possible to tamper with files without the encryption key, but it was deemed a good compromise between security and user experience. And after pondering the options, it was decided to write a tool to provide the encryption and decryption features, both as a command line interface with a PAM module and as a dbus API. That tool is called Dearlock. It is currently under active development. It is written in Rust, and it is expected to be announced publicly very soon. Very soon being a matter of days, I'm being told. Another interesting project, more specific to the gaming session, is desktop portals. So they are a standardized mechanism and a set of APIs for sandbox applications to gain access to functionality provided by the host system. A typical use case is gating access to certain hardware or files behind a user prompt, similar to permission prompts on mobile operating systems or in web browsers. Desktop environments such as KDE or GNOME have their own implementations of portal backends, but they're not suitable for a gaming session because that gaming session is a full screen surface and has no way to pop up prompts. And you don't want prompts to be popping up when you're playing anyway. So I'm currently working on a custom GameScope portal backend that implements among other things, the screenshot and screencast interfaces. In both cases, the actual functionality is delegated to the compositor, which takes a screenshot and saves it to disk, and also exposes a pipewire stream to cast the contents of the screen. The custom backend differs from existing ones in that it doesn't prompt the user, and it doesn't offer extended options like selecting where to save the image file, or cropping the captured area, or selecting a different window, these kind of things. Another interesting difference with most existing portal backends that are written in C or C++ is that this one, as an experiment, is written in Rust, and it leverages a really cool project called ASHPD, which stands for Aperture Science Handheld Portal Device, which is, by a funny coincidence, a reference to another Valve game. All right. this was just a brief overview of some of the contributions that Igalia folks have made and are making to the greater Linux ecosystem through our contracting work with Valve. The benefits are many and go way beyond the gaming universe. One important thing to highlight is that Valve has a healthy upstream-first approach. So the work on SteamOS has a direct positive impact on many upstream projects. And please bear in mind that most of the work that I've presented isn't mine. So I couldn't go into all the savory details, but I hope I managed to catch your curiosity regardless. And now, if you have questions, I'll do my best to answer them. And if I can't, I'll be happy to put you in touch with my colleagues who are the respective experts in their fields. Thank you.
I'll take a chance if it's your domain or not. About the portal, have you considered trying to extend the existing basically screencast and screenshot portal that we have and basically give a full screen application a trust to actually implement its own UI?
That's not something that I considered. I mean, the game scope session already exposes pipewire node that casts the contents of the screen. So it sounded quite trivial to implement a portal that just didn't prompt the user, basically. That's respecting the existing API.
I understand the simplicity. I'm just thinking about the other compositors that may run games in the
all right. I didn't.
Just the big portrait I was thinking about here. Yeah.
That's not a use case that's been considered, but that's an interesting idea. Yeah.
Thank you.
Thanks.
So do you know anything about contributions to wine, since it's so much maybe not by your company, but in general?
I'm not myself working on this. I'd swear we have people at Igalia working on this. There's also people outside contributing to wine, but oh,
well, that's good already.
Not my field.
Are you involved in replacing NVIDIA Blob with open source driver? When can we ditch the Blob?
I have no idea.
All right.
Sorry.
Nice talk, by the way. Can you expand a little bit on the Loveday scheduler? That was a wine game, so there was no control of Linux scheduler priorities. And what kind of background task did you run? It was CPU-based or IO-based?
That's a very good question. I didn't record that demo, and I should have done my homework and asked Changwoo what kind of task he used. I don't know. That's a very good point. It would be interesting to know exactly how exactly that task is stressing the system. Yeah.
Okay, thank you.
Since, in my understanding, that's an AMD device, so the GPU is AMD as well. Could you, I think, is it correct?
Sorry, I didn't get it.
Since the Valve deck is an AMD device.
Yeah.
The GPU is AMD as well,
Yeah.
right? Since I don't know much about that, could you brief us about what is the current upstreaming state of the support for the AMD GPUs in Linux kernel? If it runs blob,
So-
it's completely upstream. I know anything about that.
So that's not me personally working on this, but all the work is happening upstream. So all the modifications to the AMD GPU driver are happening in the open and upstream.
So I saw that you used the BPF scheduler thing. Is there any overhead of using that instead of standard scheduler?
Again, sorry, I'm not the best person to answer that. I hope not much, if any at all. You know, it's been in the kernel for some time now. Hopefully by now, any overhead, any important overhead has been ironed out. But yeah.
Okay, thanks. One more, maybe?
As far as I understand, the SteamOS is reserved for the Steam Deck and the Lenovo Legion, if I recall correctly. Will we see a day where I could install SteamOS on my own desktop PC?
Oh yeah, it's totally doable today. It's that's one of the things that I was trying to convey. It's you can grab a SteamOS image and install it on any device, and it's that's one of the important things that we focus on, making sure that it works out of the box on as many devices, computers as possible.
Do you have any timeline for this release?
Which one? The
The
work that I
SteamOS
talked about,
available
or
on any PC?
that's already available
already the
today.
case,
Yeah, you
sorry.
can download images and install them.
Okay.
And I mentioned 3.7 is just around the corner. I think the plan is to release it at the end of the month.
Thank you.
Is that only for devices with AMD GPUs though, or is it generalized?
It's better supported on AMD GPUs, but there's no reason it wouldn't work on other hardware.
Okay.
Okay, in that case, how do you manage people pirating games and stuff if you're allowing open platforms to play the games?
Sorry, I didn't get that question.
Well, okay, so I work for Sony, and we had Linux on one of our platforms, and we had to stop because people were pirating games.
Oh.
And so it's an issue with like the GPL, and requires that you support reinstallation, or there's issues there. But I'm just wondering if you have an open platform where you're putting Linux on like an average desktop, how do you ensure the integrity of the gaming experience? Or have you, maybe this is out of your...
That's not my my field, sorry.
I think we have one question from the online chat here.
All right, our first online question of the day. Is the Lenovo device using the exact same image as the Steam Deck?
The exact same?
Image as the Steam
Image,
Deck.
yes.
Thank you.
Okay, thank you very much, Olivier.
Thank you.
Great talk.
I had a last slide to say that we're hiring, but it's gone. So if you're interested or if you want to continue the conversation, please come and talk to me.